Bismillahirrahmanirrahim. How are you, students? Today we will study physics, lecture number 39, unit number 9, grade 11. Today's topic is diffraction at a single slit. Diffraction at a single slit. But before going into detail of diffraction at a single slit, first we will explain diffraction. What is diffraction? Diffraction is the slight bending of light as it passes around the edge of an object. The amount of bending depends upon the relative size of the wavelength of light to the size of the opening. So, if you look here, the size is larger. So diffraction is visible at the corner. Here in this area, no diffraction. You will see no diffraction. Here you can see diffraction. Now, here the size is smaller. Slit is more smaller. So diffraction is more dominant. Here the size is much more smaller. So complete diffraction. You will see complete diffraction. Complete diffraction. So first, diffraction phenomena is the bending of light, scattering of light, bending, scattering of light waves. From sharp edges or sharp corner. If the size of slit is equal to the wavelength or less than the wavelength, then the diffraction phenomena will be dominant. It produces color pattern. Now, single slit diffraction. You can see single slit in the given diagram. Now, when a light passes through a small slit, it spread out and produces a diffraction pattern showing a principal peak with subsidiary maxima and minima of decreasing intensity. So, if you pass white light through a single slit, it will diffract in different color. It will be diffracted in different angle according to their wavelength and frequency. When light goes through a narrow slit, it spread out to form a diffraction pattern. Now we want to understand this behavior in more detail. Incident light of wavelength lambda. Single slit. So we will pass light through this, and then you will see that light will be diffracted at different angles because the bending of light will be according to the wavelength and frequency. Now, diffraction at a single slit. Single slit diffraction pattern. Monochromatic light passed when a monochromatic, this is single slit diffraction pattern you will see on the next page. Monochromatic light passed through a single slit has a central maxima and many smaller and dimmer maxima on the other side. The central maxima is 6 times higher than as shown in the diagram. Now, if you pass white light through a single slit, here is the slit, it will be diffracted in different at different angles. This will have bright fringe, this will be dark, bright, dark, dark, bright, dark. So you will see a series of fringes, dark fringes and bright fringes. Maxima is called bright fringe, bright fringe, and minima is called dark fringe. So it will be, you will see different pattern. Single slit diffraction. The finite width of slit is the basis for understanding diffraction phenomena. According to Huygens principle, each portion of the slit acts as a source of light waves. Therefore, light from one portion of the slit can interfere with light from another portion. For example, light is coming from this, so this is primary source. Here, these dots will behave as a source of secondary wavelets, and this will interfere with this either constructively or destructively. Each point 1 and 2 will either interfere constructively and destructively. Might be they will interfere constructively, but 1 with 3 will interfere destructively. So it depends on the path difference of the two light ray. Path difference. If it is half integral multiple, it will interfere constructively, destructively. If integral multiple, then constructively. Now, here you will see bright fringe. Its width is maximum as compared to other. This is dark, bright, 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 bright fringe, bright fringe, bright fringe, dark, 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 dark. Now, light passing through a slit, single slit, forms a diffraction pattern somewhat different from those formed by double slit or diffraction grating. Single slit diffraction pattern you can see in the diagram in your book, check it. Note that the central maxima is larger than those on either side, and the intensity decreases rapidly on either side. In contrast, a diffraction grating produces evenly spaced lines that dim slowly on either side. If you see from this, light intensity decreases. Here light intensity decreases. Here light intensity is maximum. Wavelength is maximum. Now diffraction grating. Diffraction grating is a piece of glass. Is a piece of glass on which lines are ruled with diamond sharp edge. Lines are ruled. In optics, a diffraction grating is an optical component with a periodic structure that split and diffract light into several beams traveling in different directions. The emerging coloration is a form of structural coloration. For example, if you place a diffraction grating here and you pass white light, it will be diffracted in different direction. At different angles. This will be violet, this will be indigo, blue. It will split white light into its component color. White light into its component color. Now, a device that breaks an electromagnetic wave into different frequencies by scattering them at different angles. For example, a series of thousands of scored lines in a glass plates diffract light into a rainbow colors. Lines of data bits on a CD give the same effect. So, if you place grating element here, and you pass white light through it, it will be diffracted at different angles. This phenomena is called diffraction, and this is called grating. Lines rule per centimeter must be more than 400 lines. Per centimeter you have to draw, the minimum lines is 400. Now you can see incoming beam of light. This is diffraction, a grating element. This is the color pattern you obtain. Analysis applied to individual color. "500 lines per millimeter linear diffraction." This is the picture taken for a diffraction grating having 500 lines per millimeter. 300 to 700 wavelength applied can be predicted. You can see, trace this line. Basically you can see the diagram now. First step, a broad spectrum lights halogens incandescent is shown through a sample experimentation. Some color are absorbed more than other depending on its composition. Diffraction grating splits light into colors so they can be measured separately. This is diffraction grating. A webcam measures each color and graphs their intensities. This is compared to known sample. Now, spectrometer for producing light of any selected wavelength, or color photometer used for the measuring the intensity of light. The two devices are placed at either side of a on either side of a liquid or anything. Simple, you can take source of light source. This is slit, this is slit, this is prism, this is another slit, this is any container having liquid, this is detector, readout device. Now you can see the diagram. X-ray crystallography, that is the next coming topic. We will go back. First we explain diffraction phenomena. Diffraction phenomena is the bending of light around sharp corner and edges. The bending of light around sharp corner and edges is called diffraction phenomena. Diffraction is the light bending of light is slight bending of light as it passes around the edge of an object. The amount of bending depends on the relative size of the wavelength of light and to the size of the opening. Single-slit diffraction. When light passes through a small slit, it spread out and produces a diffraction pattern showing a principal peak with subsidiary maxima and minima. Here the light intensity will be maximum. If you go in this direction, light intensity decreases. If you go in this direction, the light intensity decreases. Single slit experiment. When light goes through a narrow slit, it spread out to form a diffraction pattern. Now we want to understand the behavior. Diffraction at a single slit. Single slit diffraction pattern, monochromatic light passed through a single slit, has a central maxima and many smaller and dimmer maxima on either side. The central maxima is 6 times higher than the others at the other ends. Single slit. The finite width of slit is the basis of understanding diffraction phenomena. According to Huygens principle, each portion of the slit acts as a source of light waves. Therefore, light from one portion of the slit can interfere with light from other portion. Now, the equation for diffraction phenomena is d sine theta is equal to n lambda. This is the equation for diffraction phenomena. The central maxima is of the highest intensity and all the other maxima are of lower intensity. This will have maximum intensity. Maxima intensity. Notice that if narrow slit is used, then the angle theta increases. Here the angle increases. Here the angle is 0. Here 10, 20, 30, 40 and so on. But the intensity of light of the bright fringes decreases. If you go in this direction, the intensity decreases. In this direction, the intensity decreases. It will be maximum at the central region. Light passing through a single slit forms a diffraction pattern somewhat different from those formed by double slit or diffraction grating. The central maxima is larger than those on either side, having maximum intensity and larger in size. And if you go from the middle region to the edges, the intensity decreases. Diffraction grating is a piece of glass on which lines are ruled with diamond sharp edge, and the minimum lines must be 400 per centimeter. The minimum amount is 400. More will be the line, more dominant will be the diffraction pattern. A device that breaks up an electromagnetic wave into different frequencies by scattering them at different angles. For example, a series of thousands of scored lines in a glass diffract light into a rainbow colors. It behave like you can see color pattern in the CD. You can see 500 lines per millimeter. The diffraction pattern obtained from that is shown on the screen. The equation for this is diffraction grating is d sine theta is equal to n lambda. Now I will write something. The width of the slit is called grating element. Grating element represented by D, where D is this. Its value is obtained by dividing the unit length of the grating by the total number of lines ruled on it. D is equal to 1 unit length, which we take in centimeter. If you consider millimeter, take millimeter, divide by lines ruled on millimeter. You will get this one. N is the number of lines. Ruled. Number of lines ruled. Spectrometer is a scientific instrument used to separate and measure spectral components of a physical phenomena. Grating spectrometer is used to calculate the wavelength. Spectrometer is a broad term used to describe instruments that measure continuous variables of phenomena where the spectral components are somewhere mixed. In visible light, a spectrometer can separate white light and measure individual narrow bands of colors called a spectrum. Mass spectrometers measures the spectrum of the mass of the atoms or molecules present in a gas. The first spectrometer were used to split light into an array of separate colors. Spectrometers were developed in early studies of physics, astronomy, and chemistry. In spectrometer consists of monochromatic light, collimator, and a telescope. With the help of these instruments, collimator collimate the light ray, make the light ray beam parallel. Then diffraction grating is used, which diffract the light ray, and telescope is used to calculate the wavelength of light. Thank you, students. Allah Hafiz.